Alright, in this video, I'm going to show you how you can use U-Substitution to solve an integral. So let's say you were given the integral of 2x multiplied by 4x squared plus 10 cubed dx. And looking here, we have two polynomial expressions being multiplied together, but one of our polynomials is being cubed. So because of that, we can't just integrate using the basic antiderivative techniques, such as if we had the integral of x squared dx, here we could just say, well, this is simply 1/3 x cubed plus c. But because of this cube here, we can't, the same rules don't apply unless we were to use algebra and expand that out. And I know the more neurotic of y'all might say, well, that's fine, I'll just brute force it. But I have another way of doing that, and that's through U-Substitution. So what we can do is we can take one of the terms in our integrand here, either the 2x or the 4x squared plus 10, and I can set it equal to u. So what I'll do is I'll take the 4x squared plus 10 term, and I'll set it equal to u. And I chose this term because by taking the derivative of it, which is 8x dx, I can rearrange this equation to solve for dx, which gives me 1/8x du, and I can plug this back into our integral. So I'll have the integral of 2x over 8x u cubed du, and I'll see that because I chose 4x squared plus 10, my x's cancel out, and I'm left with an integral that's going to be in terms of u. So I get 1/4 u cubed du. And this looks a whole lot like that integral I showed you earlier, which was the integral of x squared dx. And this we know we can solve. So let's go ahead and solve our integral, which will give us 1/4 multiplied by 1/4 u to the 4th plus c. And now all we have to do is take our expression that's equal to u and plug it back in for u to get an answer in terms of x. So we'll have 1/16 multiplied by 4x squared plus 10 to the 4th plus c. And that is our answer. Alright, so with that, let's go back through the steps and see what we did. So what we did is we took one of the terms from our integram and we set it equal to u, realizing that the term that we chose was going to be differentiated and set in terms of dx to plug back into our integram to cancel our x terms. So just as a helpful tip, when you're looking at these problems, if the term that we were setting equal to u is more than 1 degree higher than the other term that we're leaving in, the U-substitution rule wouldn't have worked, because imagine this was 4x cubed plus 10. Well, we would have got 12x squared here, so we would have been dividing by 1/12x squared. And when we bring it back in, we would have had 2x over 12x squared, which would have left us with an x here in our denominator. So we would have had to use another method if the term that we're using as u is more than 1 degree higher than the term that we're not using as u. Okay, so that'll get you going with solving integrals using U-substitution. If you found that helpful, leave a like. If you have any questions, leave a comment. And if you want to see more, go ahead and subscribe. Thank you.